Hi, I'm Clarissa Lopez, and today I will be doing my lesson over lateral area, surface area, and volume of a cone. Going over lateral surface area, the sum of the area of the lateral surface leaves off, and then you leave off the area of the bases. So what that means is, with this cone, it has this base, right, of this circle. But lateral surface area is where you're gonna leave that base off. That's what I've stated right here. So that means you're just gonna find this area, the outer top area, just like this top of it. And the formula for this lateral surface area is pi r slant. So what that means, that slant right there is on a cone, there's a height, there's a slant, and then there's either going to be a radius or sometimes they'll give you a diameter, but you always want it to be a radius. So whatever that diameter is, obviously you have that, or it can just be given to you. That being said, with our example we'll be working with today, luckily they give us our slant. So let's go ahead and mark that. So that'll be our slant, this is our height, and this is our radius. The thing with lateral surface area is people tend to want to use the height instead of the slant. So we want to avoid doing that as much as possible. So what we're going to do is plug in our numbers here. So pi, our radius is 15, and our slant is 25. So all we need to do now is plug that into our calculator, and that's 375. And we're gonna leave pi the way it is. We can always put it in, but we're gonna leave it like that for now. So this is our answer. They did not give us any units, but it is a square, so we are going to put units squared as our answer. Okay, so I know we mentioned surface area. And surface area, and we'll come back to this example in a second, but surface area is the area of the bases plus the lateral surface area, and it adds the area of all of the surfaces. So with our cone, like I stated in our lateral surface area example, I just marked the base, right? But with surface area, this time we're going to include the base, so we're going to include all of this, right? So that's literally everything on the outside. That's what we're finding, the area. And the formula for that is pi r, our slant again, plus pi r squared. And notice that this is the same as our lateral surface area. So we're adding that to this to get our surface area. And remember, it is height, slant, and then radius. So going back to our example here, we can go in and we can plug that in. So remember, pi r slant plus pi r squared. And luckily we're given our radius again. We're going to leave pi the way it is. And we're just going to plug this in. And remember, radius is 15, but we're going to square that. And notice that we already know this number. It is 375 pi, because that's what we got up here. And then right here we're going to do 15 squared. And we know that is 225 pi. These have obviously like terms, so we'll do 225 plus 375, and we get 600 pi. We don't have any units given to us, so we would just put units squared, and that is our surface area. And like I mentioned, surface area is just the outside of the shape, our 3D shape. But going forward, we're going to look at our volume. And volume is different because volume is how much space a three-dimensional figure will hold. So looking at our cone, it would be like if we were to turn this upside down and fill it with water or something like that. It's just how much that shape can hold. So the visual could be like surface area, but instead of using that other color, we're going to use this color to represent, liquid or whatever it may be that could fill our shape. And the formula for volume is 1/3 base, or area of the base times height. So notice we have two new concepts here. The B is area of base. And we know that our base is this circle, right? We've stated that before. That is our, I'm sorry, the colors are kind of similar, but that's the base. And we have to find the area of that. And then, like we stated before, this is our slant, this is our height, and then this is our radius or diameter. But we're not using L anymore, we're using H. So we have to take that into consideration when we are looking at our example here this time. So we'll come down here and we'll look at this formula, which is, like I said, 1/3 area of base times height. We know that we are given this L and we are given our radius. But looking at our area of a base, our base is a circle. We know that the area of a circle is pi r squared. And so we can plug that in. And height, we don't know height. So we're going to have to come over here. We're going to have to use Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. And we know that c squared is always the slant of a triangle, right? So that is 25 squared. And these don't ever matter, so we will just say b is 15 squared, and we're trying to find a squared. So let's do a squared plus 15 squared is 225, and 25 squared is 625. I'm running out of room, sorry. To get that, we have to subtract 225 and we get 400. So a squared equals 400. I don't believe, oh yes, so square root of 400 is 20. So a equals 20. So we now know our height. And so we can put that in as well. We did do pi r squared up here, so we did know that it's pi times 15 squared times 1/3 times 20. And we can come back up here and 1/3, and we know that that equals 225 pi times 20. Let's do 20 times 225 is 4,500 pi times 1/3. Let's do 4,500 times 1/3 is 1,500. So our answer is 1,500 pi units. And because it's a volume, we have to remember that it is cubed. And that is how we do it. Thank you for watching.